So this is the second chart, and this is like the most important one because it helps us compare the important timeline events on the x-axis to the number of cases. We have two sets of data here. The yellow bar represents cases by the date of diagnosis. Basically, the yellow bar is the ones that the doctors and the officials know about, meaning the day that patients were confirmed with coronavirus by doctors. The gray bars are the actual number of cases, meaning the day that when the patients had confirmed coronavirus but did not notify the doctors or officials. So it is important to note that each new bar represents new cases and not the total number. This is very alarming, since in the early stages, many people already had coronavirus, but the doctors did not know, but the doctors were not notified. When the cases started multiplying at a dangerous rate, like from here, this is our actual cases. The health officials locked down the city. So then, which is the epicenter of the coronavirus, which ultimately showed that the total number of cases lowered from here, and it just halted and started going down after multiplying exponentially. And after the officials realized the seriousness of this coronavirus, they started documenting more official cases, which is why the yellow bar started rising. However, as diagnosis cases grew, which is not a bad thing, since now we can treat them officially. On January 21st, for example, which is around right here, the officials knew that there were only 100 new cases, when there were really 1,500 new cases here. And if we total it up from all the way here, all the way to January 21st, the total cases, the officials thought it was 444 from the beginning, but the actual total cases was 12,000. Okay, this shows like these smaller lines that are not growing are Asian countries. For example, South Korea, Japan, Philippines, and etc. And these are the Western countries. And one reason why the Eastern countries had more experience with this coronavirus is due to the SARS outbreak, which gave them a lot of experience on how to contain the virus and how they collect the data early. Okay, so this is a comparison between Eastern places and the Western places. And this is a chart of the Washington state. The Washington state is like the Wuhan of the US because their cases started actually multiplying from here. And when the officials documented it, it actually just peaked in a few days. Okay, thank you.
Okay, great. So first off, we have a few questions inside the chat section. So the first question is if you could please go back to your slides. The one before that slide. No, I mean the third slide. The third slide.
Okay.
我没 mute 呀，我把它 unmute 了。Okay, so the question in the chat was, why is February 1st of 2020 so high?
February 1st?
Yeah.
Oh, so that was because right after the lockdown, the officials started this program to document the new cases. Before, there weren't even any like official cases, but after the documenting started, they realized how many, they started like more intensive programs to capture like a wider population. So that's why they had more like specific data.
Okay.
And
all right.
higher data, yeah.
Okay, so that was the question. And also, you can stop sharing your screen now. And also, so our meeting host, Jason, is here. So Jason, next time, please come more early because you're the meeting host. And can you please open your camera? I can't hear you.
Was that? So we can hear the next. So now we can have the next person go.
Which is Victor.
One more question for the first one.
You lagged out, Jason.
I was saying that Victor could go now.
Oh, okay. I didn't really find graphs, but I did like another thing. I need to share my screen. Wait, it's not allowing me to share my screen.
What does it say?
It says allow apps below to record the contents of your screen while using other apps.
Wait, can't you share screen and click the share screen button? You can't?
No.
Oh,
Wait.
okay. You see the green button?
Yeah.
It says share screen. Is it that
When I
one?
click it, it says preferences.
You pick an application.
Okay, well, I could share my screen. I mean, like... Is it just your computer that can't share the screen?
Wait, can you see it?
No, we can't see it. Oh, now we can see it.
Oh.
Okay.
So basically, this chart is about COVID-19, and my question is, what province in Canada has the highest chance of recovering? The provinces that I chose for this are Alberta, British Columbia, Saskatchewan, Quebec, and Ontario. The reason why I chose these provinces is because they had the highest cases of COVID-19 in Canada, because if I chose somewhere like PEI, which only had 5 cases, they're probably going to have a higher chance of recovering because they only have 5 cases. So for the formula I used to calculate this is the number of favorable outcomes over the total number of favorable outcomes. Basically, this means recovered cases divided by the total cases, and it will get a percentage. So, for example, BC recovered cases, there are 2,153, and the total cases are 2,558, which if you divide those, it would be 84, so it would be 84%. And I guess for Saskatchewan, it kind of cut out there, but Saskatchewan, there's 639 total cases, and 568 recovered cases. So then it would be, if you divide those numbers, you would get a percentage. It kind of cut out. For Quebec, there's 49,702 cases. There's 15,618 cases. So basically, it would be about approximately 31% recovery rate. for Ontario, there's the amount of recovered cases is 2,153, and the total cases is 2,558. So it'd be about 77%. And for Alberta, finally Alberta, there's the total recovered cases, which is 2,153, and the total cases active right now are 2,558. So there's an 89% recovery rate. And that's it. Yeah.
Okay, wait 1 sec. So in the chat, Jason or Jijon had a question about why are all the numbers the same, but I don't see any of the same numbers. I mean, like, Jason, Jason or Jijon, can you please point out where it's like the same numbers?
The graph, the recovery is always 2,153 and every single 58.
I think that's a typo. Just look on the graph on the top left corner. And Sophie also had a question. Yes?
Oh, the same question.
Oh, okay. Okay. And so I have a comment. My comment is that this is a very effective way of finding the recovery rate, because normally because let's look at death rate. To not have panic, lots of people just say, well, the death rate is, for example, inside a population of 1,100,000 have died. And so they're like, well, the death rate is then going to be 1 in 10,000. But then there's also but then that's not very correct, because if you get the coronavirus, you don't care about the population's death rate, you care about your own death rate. So then we have to look at the coronavirus cases and also the death cases. So for example, if there were, let's say, 2,000 cases, then that means inside the 2,000 cases, 100 have died. So the death rate is 1 in 20. And another question was from Kevin, is when was this stated?
I got it from yesterday, actually. It was from Health Canada, so.
Yeah, okay.
Yeah.
Well, anyways, so and Jason, just to tell you, next presenter is going to be me. So first off, before we continue on, I'll show you guys a website where you could find all of like these dates. So I'm just going to share my screen, but 1 second. Okay. All right. So first off, on this website. So I know it's a Chinese website, but this website is pretty accurate, and there's a lot of data on this website. So you can see like the progression of the virus. So first off, this is just the data from Canada, and we can see the progression of the virus via this chart, and we also see like the current amount. And I'm pretty sure this hasn't updated, because it says 新确诊, which is basically the new cases of the day. I don't think it's updated. That's why it's saying 0. So, and there's also like the 日增速. They didn't get the newest data yet, so it still says 0. And now looking at the chart, so first off, we have the 累积确诊. Did you want to say something? Wait 1 sec.
His internet is really bad.
Yeah, Jason and Jijon, I didn't catch what you said. So continuing on. So this is the confirmed, all of the confirmed cases added together. So even if you recovered, then your case is still listed on the 累积确诊. And then there's also the 新确诊, which is basically how much new cases there were today, and it hasn't updated yet, so that's why it says 0. And then there's 现存确诊, which means the people who have the virus right now. And then there's also 感染率, which is basically I'm pretty sure it's the average infection per day, which means that, like, for example, today there were 2,000 people that were infected. Tomorrow there were 3,000 people that were infected, and the next day there were 2,300 people infected. So that's that. And then we also have 日增数, which is basically the percent of new positive and all positive. So like the new positive cases divided by the all positive cases, and then we make it into a percent. And then there's also a lot of other things. There's also 死亡, the death rate, and it's not very cheerful, and so on. And then we see here, we have a graph, and this graph is the 累积确诊 right here. So, which means that this graph is the graph of all the cases stacked up together, so it doesn't account for recovery. And also we can see here that this person who has made this website for tracking the coronavirus only starts with like the 100s, which means that you see my mouse is like on the very edge of the graph. And all of these, we can see there's 121, 119, 110, 109, 104, 103, and so on. We see that they're all in the hundreds. So like this person who made this website, because usually the people who make these types of websites have to like get data from all types of sources and put them together. So then we see that this person doesn't think that the amount of cases that's lower than 100 is accurate. So this person only did numbers that are larger than 100. And somebody had a question in the chat. Can you please say your questions out loud because I cannot see the chat?
By new positive cases, on the last slide, when you said new positive cases, how recent are you talking when you say new positive cases?
So this 新确诊 means that, so for example, if we look at it again today afternoon, then it'll probably update and then we'll see the amount of new cases of today. So good question.
I have a question too.
Yeah.
So Canada should include all the provinces, right?
Mm-hmm.
So why it's not on the top? Like, yeah.
This?
The curve. I mean,
Yeah, well, I'm not sure about that one. It's probably just the data that was collected. Yeah, exactly that part. Maybe like yeah, I'm not really sure about that either. You'll have to ask the person who created this website.
Okay, thank you.
Yeah, all right. So now moving on, we also have like every province and like we have the shapes of these curves. Oh, 明白了. Okay, so basically, okay, so my dad answered that question. So basically, you see here that these different like the lines have different endings. This is because we start with different days. Oh, okay. And we see here that x 轴为自100起确诊为来天数, which means that the 0 day means the first day of when each province had more than 100 cases, or country in the case of Canada. So then that means that the 0 day of Canada is earlier than the 0 day of Quebec, which is 癸申 121, so the blue line here. So that's why it seems like on the graph that the Quebec is like larger than Canada, but it is a fact that the Canada started earlier than Quebec. So if we're on like this point, we see that Canada right here, we have this dot. This dot is like a few days or a few weeks earlier than this dot. Yeah, so like every website have their own ways of expressing data. Yeah, so really good question. And also, if you notice on this chart, you see we have 100, 1,000, 10,000, 100,000. So that means the scale of the chart on the y-axis is not actually how this, it does not make this chart actually how it looks. It's just like compressed, it just compressed sections. So for example, the 100K to 10K, the 10K to the 1K, and so on. And then right here, we also have the graphs of certain provinces, and we see that this is so first off, we look at the 日期. So if you look on the right on the graph, there's the 日期, so the day, and then we also have like 4月1号, so April 1st and May 1st. And so we see that basically on this chart, it's different from the other chart, where on this chart it's how many days since the section, the region, the province, or whatever, at first had more than 100 cases. That's day 0. But on here, it's all about April 1st, May 1st, and etc. And also, if you notice the scale is like some scales are more compressed than other scales. And that's about it. So that's this
Got a
website.
question.
Yeah?
Why did they copy like all like the graph and this thing from the Canada official website?
But they didn't really copy. There's if you search online, it's really hard to search for these type of graphs. You can only see like how much you get for every day. So this person, what they did is this is what they probably did, because we don't know exactly how they did it, but they probably had like this online tool, yeah, net spider. So then they like what's a net spider? So basically the net spider just searches online and the data mines, just mines for data, and then like filters the data and gives you useful information. So the net spider searches up, like for example, COVID-19, and then it goes to all the websites and it looks for all the data. So that's how they got this information.
Oh, okay.
Good question. Yeah. And then there's also the same website, and this is for the world. So like we have again Chiajin.
I have a question.
Yeah.
Why is the graph constantly changing?
Which graph? This graph?
Yeah, that one. That one.
Oh, okay. So there, basically, if you explore on this page, you see that wherever your mouse hovers over, then we see here down here there's a 35. So 35 days after the first day in which each region had their first 100 or more coronavirus cases. And then, so basically, it's saying like after how many days from day 0, how many cases there are. So that's why it changes. So like the different days of the different cases. Okay, so continuing on, we have Chiajin. So the total amount of confirmed cases ever, and Xinchiajin, the new amount of cases, and we see that it's already starting to update. See, we have some blank. So some blank means that they still haven't we still haven't found the data for for these regions, but some we have like plus 99 more cases. And there's also swan death and new death 1,164. And then we also have ganran per 1 million people. So that means, so for like what this means is that for every 1 million people, 778 people are infected. And then this is the death rate, and then this is the death rate per a million people. So like what I was saying earlier, there's like the death rate in a population and the death rate for the coronavirus cases. And there's also recovery, and then there's other stuff. So, and we see that USA, we see that this down arrow means that we go from the most cases to the least cases. So USA has the most cases currently of now. Yeah, And then we see there's all these small countries that have like 2 cases, 5 cases, and so on. Okay, and then we see here, it's basically the same like graph, but except it has like every single country. And yeah, and they're all different lengths because like what I explained before, these two are made by the same user, these two websites, these two data places, whatever. So like basically we see that China is the longest one because China had the coronavirus for the longest. So like China started with the coronavirus and then other places went too. Yeah, and exactly. So basically, it starts with the day 0 is basically the first 100 cases, whatever has the first 100 cases. And also, we see that if we hover over the China graph, we see it starts with 526. It's probably because they haven't started recording like the China coronavirus cases yet, like the Chinese government and such. And then there's also the Canada graph again, and that's it. And now we have another website. So if you don't like using Chinese websites, this is an English website, but this is about USA. So we see that there's cases here, there's deaths, there's fatality, and there's recovered. So, and we see in USA there's like New York, New Jersey, Illinois, California, and so on. Yeah. Okay.
I have a question.
Yeah.
Can you like scroll down to like the charts? What do like the icons beside the provinces mean?
Oh, let's see. Okay, wait. I need to find if is there a key? Yeah, I'm not sure. I'm trying to find it. Yeah, okay. Yeah, there's no key on this as well. I haven't found a key, so you could look for it after. But like, yeah, I'm not sure about that. Anyways, so that's it for like all the coronavirus data. And then so first off, if you guys want like the websites, I can like send it to you guys later if you guys want to monitor coronavirus. But anyways, so I'm going to stop sharing my screen and I am going to, yeah, so if anybody else has anything to like talk about.
I have a little more to talk about.
Mm-hmm.
So I'm on iPad right now, so I can't screen share.
Yeah.
Okay, so I just wrote it down. So I figured out that most of the cases at the beginning were taken without measures. So people just thought that it was a regular fever and didn't use proper methods to treat it. And that's how most of it started to spread because it was near Chinese New Year and most people were going to visit China. So that's how it started to spread so quickly. So I figured out that Washington has one of the most cases has probably the most cases in the US. And on January 20th, the case started out with 282 in China. Not much of the world was bothered. And then on the 21st, January the 21st, 314 were infected. And then on the 23rd, 581 were infected. And on the 31st, which is the last month of January, two people of the same family test positive in China, and there was 2,000 cases. So that was from 581 to 2,000. So on February the 11th, there was 43,000 cases in the world and 477 deaths. So the coronavirus, there's transmission from person to person who has symptoms with a 3 feet radius, and the symptoms can be hidden. So even if you don't know that that someone has a coronavirus because they're not showing symptoms, they can still infect you. So that's why social distancing is really, really important. And for my other things, I'll just review what Xixiang's graphs were about. They were about basically the number of cases in each country and like the growth rate and like how many daily countries have people infected. So yeah, that's basically my research on this topic.
Okay, great. One sec. All right. So,
May I
okay,
speak
great.
now?
Okay, sure.
Okay, so what I researched was about coronavirus. Was, as most of you know, it's a respiratory syndrome, so it invades your lungs usually. But I went into research about a little on how it infects you. So basically, how the coronavirus infects you is like, as most of you have probably seen an image of the coronavirus, it has like these little spikes on its body. And these spikes are actually protein. This is an example on how protein is actually not good for your body, because the cell uses these protein spikes to trick your cells into letting it past your system that kills off all the disease that enters your body. And once it is in your body, because it tricked the cells into getting into your body, it goes into one of the cells and it takes off its protein armor and it invades the cell and hijacks it to produce more of its copies. And then the cell that hijacked basically dies. And then once they produce a lot of these cells, then your system may have already been too late for your system to notice that something was wrong. So basically your system would probably be in a panic and it will start sending a bunch of disease killing cells of your own to attack the virus. But this isn't actually necessarily a good thing, because if your cells goes crazy and sends a bunch of disease killing cells everywhere, it can actually tremendously negatively affect your health in a very bad way. And yeah, it is immune cells. I forgot the term. Also, sometimes you will just eradicate, your immune cells will just eradicate the virus, and that is what mostly happens. But if the virus has made it to like your lungs, then that's when things are going to get really dangerous, because, well, obviously there's going to be a huge fight there in your lungs, and if the virus keeps on making it down your lungs, then they're going to like get to this place where it's like a bunch of balloons, and they're the things that like help you breathe.
Ventilators.
Yeah, ventilators. Wait, no, not ventilators. Because once like the virus invades those balloon things that help you breathe, that's when ventilators are like a life-saving need for you, or else the virus is just gonna kill you, basically.
Yeah, well,
Also,
yeah, so it's basically like immune system overdrive where like you're trying to attack the cells, but instead of
everywhere, and then so your immune system just goes crazy and it's like these like little flesh balloons that help you breathe, and if the virus invades there, then you're pretty much dead, unless if you have a bunch of medical support.
Aren't those lungs?
I'm pretty sure they're lung cells.
Okay,
Yeah,
anyways.
alveoli. Yes, alveoli. Yes.
All right, Harrison, your turn.
And that's basically all.
Of getting it, and also who is most at risk of getting COVID-19. Is that okay?
Yeah, okay. Present
Okay.
anything you want.
So COVID-19 is a serious health threat, and the situation is evolving daily. The risk will vary between the within communities, but given the increasing number of cases in Canada, the risk to Canadians is considered high. This does not mean that all Canadians will get the disease. It means that there is already a significant impact on our healthcare system. If we do not flatten the epidemic curve right now, the increase of COVID-19 cases could impact healthcare resources available to Canadians. We continue to assess the public health risk based on the best available evidence as the solution evolves. So like that's what they're researching right now. So while COVID-19 can make anyone sick, some Canadians with specific health circumstances are at an increased risk of more severe outcomes, including individuals that are aged 65 and over, with compromised immune systems, and with underlying medical conditions. In addition, social and economic circumstances may also be a factor in identifying someone who is vulnerable to COVID-19.
Is that it?
Mm-hmm.
Okay, all right, great. So we have the COVID-19 cases, the COVID-19 development history, how COVID-19 affects your body, and who is at risk. All right, great. So I have one more thing to share with you, or two more things, depending on our time. So first off, I'm going to screen share, and this is about infection models. So because COVID-19 is like you infect the COVID-19 to another person, so we can basically count it as like sort of an infection model. So this infection model is called the SIR model, and I'm pretty sure some of you guys have already watched the video that was sent. So the SIR disease model. So SIR. So what does SIR mean? So first off, let's say we have a population P. So we have the population. And S is the susceptibles. So S of T is the susceptibles. So it's a susceptible. So the number of people at a time T who could be affected. And what exactly is susceptible? It means that, for example, we have like the infected people, the people with a virus, and the people who have already recovered. And then there's also, and so the people who do not have the virus or ever had the virus are the susceptible people. And in some cases, susceptible is only the people who does not have the virus right now, which means that even if you recovered, you're still susceptible. So it depends on the case. And then, so why is it, first off, why is it T? It's T because, wait one sec, somebody said something. So why is there a T here? Because for example, if we have like, so first off, let's look at a function. So who knows what y equals x describes? So y equals x, you can describe it on the xy axis. So it's a line. It's a line that passes through the middle. So y equals x, so for example, we have an x-axis and a y-axis. And so whatever value x equals, y equals that. Yes? You're lagging again. Are you trying to speak? Because I can't hear you. Okay, well, never mind. So
Okay.
there's also, huh? Oh, Jason and Jijon, 9:40 is the time. Okay, there's no rush, guys. You don't have to rush to Chinese school. It's not a 5-minute drive there, so. Okay, and continuing on, we have y equals x. So basically, y equals x, we can describe it as also fx equals x. So a function of x. Can you guys, so either you guys open your mics or don't spam in the chat. Oh, okay.
Okay, so for the ST,
Yeah, okay, I get what you mean, Jason. My bad. I'm sorry. Okay, so so for the ST, the T means time. Yeah, so the S is susceptible and the T is time. You'll see later. So for example, so continuing on, we have a function of x equals x. So a function is basically you do something to the x, and then so basically this side is the function, and then this is what happens when you do something to the x. That's how we describe what happens after you do something to x. So for example, we also could have fx equals x squared. So which means that if you get an x value, what you have to do with a function is you square it by x. And it doesn't have to be an f as a symbol. It could also be s. So we use s because it stands for susceptible. So susceptible is like the amount of susceptible is a function of time. So in the brackets, we have what thing we're going to make a function of. And I see somebody has a question in the chat or something. Yeah, so SIR. But and now we're understanding what it means. So then we see that the T. So for example, we have like ST. So the amount of people that are affected at time T. So the number of people who could be affected at time T. So the number of people who are not infected or have recovered at time T. So this could be a function of t, for example, t squared plus t plus 1 or something like that. What this means is basically like the amount of susceptibles changes with the time. So as time goes by, the number of susceptibles change. So it gets less and less because more people get infected and recovered. And then because in a population, there are only a number of people. So that's susceptible. And then for the SIR, we have I. So infective, IT. So what is infective? So infectives. Does everyone already understand the videos? I'm not sure. Okay. So if I'm not sure, I'm just going to explain it because some people might not understand the video. So and I of T, so the infectives is the number of people at time T who are infected and can transmit the virus. So you have the virus on you right now, and you're not a recovered or you're not susceptible. So then I of T is basically same concept as S of T. So the infectives, the amount of infectives change with time T. So like we have more infectives over time. And then at last we have R of T. So R of T equals the recovered. So the recovered is not infectives, so they don't infect people, nor the susceptives. So they're not susceptible of catching the disease. They've already developed an immunity to the disease. So the reason it's R of T is because it changes with time too. So the more time, the more people recover. And then, but there's also it's not always SIR, there's also SEIR. So what is the E? So we have S to E to I to R. So E is exposure, exposed. So E is exposed. So let's consider this model. So first off, we have S to E. So S to E is the amount of susceptibles that are going to be exposed. So with this model, we can see the effectiveness of quarantine, because if we reduce E a lot, then that means we reduce the amount of infectives and the amount of removed. So, and we also have E to I. And then we also have I to R. So let's go through them one by one. So first I'm just going to erase this. So first off, we have ST to E. Okay, so Jason or Jajon said that if we reduce E, we reduce everything. Yeah, you'll see. So basically, then that means then the amount of E is going to be like the amount of people that are exposed. So, and now we have E to IT. So E to IT. The probability of being affected is proportional to IT. Why is that so? Because the more people that are infected, the more people pass on the virus. So that means it's proportional. So proportional, I'm pretty sure it's this symbol. Yeah, I think so. To IT. And it's also proportional to E, the people who are being exposed, and also this should be ET. And it's also proportional to ET, because if you're not exposed, you can't really catch the virus. So for example, if we only have one exposed person and we have like three exposed people here, that means the infectives will infect more. So it's proportional to these two values. And then we have IT to RT. So IT to RT, what is it proportional to? So so this is proportional to IT. One sec. Why is it proportional to IT? Because the more people that are like that have the disease, the more people that will recover. It's not a percentage, it's the amount. So the percentage would still stay the same, because if we have like the amount of infectives reduced, we have the amount of removed reduced. So the proportion is still the same, but the more the infectives, the more the removed. Well, removed is okay, isn't it? But we still don't want that many infectives. So where did we get that many infectives? Well, we got all the infectives from the exposed. So that means if we reduce the amount of exposure, then we get infected slowly, which means that medical resources can keep up. So, for example, in the cases of Wuhan, when there were like tens of thousands of people and there was not enough medical supplies for all of them, it was like that's why it was such a big thing, because there was not enough medical supplies. And if we reduce the amount of exposure, then still people will get infected, but they'll get infected over a longer period of time. Which means that after they get infected by a longer period of time, there will be more medical resources to support all these people. So that's why we do quarantine. All right. Okay, Jason, host. Jason, can you hear me? Okay, great. All right, so I'm done my speech. Do you have anything else to add on?
Yeah, I'll just kind of review what you said.
Okay.
So first, you guys probably know that infections can be transmitted, and we're thinking, once the disease spreads and once it's removed, the person will become immune. So we're going to label them as removed, which is R in the SIR model. So basically, the S is the susceptibles, and Tishon already explained that they're the people who could get infected, and I is the people who already are infected, and R are the people who are cured or immune. So the SIR model, we use it to track the spread of a disease like COVID-19. So this is all in time. So we need to make sure that we're in the right time and not like 10 years before. So basically, Tishon did a pretty good job of explaining everything. And he also explained the SEIR model, which includes basically the people who are trying to prevent it. So basically, if you reduce the number of E, then the number of S and R will also go down. That's good. So basically, if there's a large number of Fs, then lots of people will be transmitted. But so if there's a small number of E, then the disease would probably spread really quickly. Just like COVID-19, if you aren't aware about it, you won't be trying to prevent yourself from getting it. So that's why it spread so quickly. So basically, Tishon did a pretty good job of explaining everything, like all the models and stuff. So yeah, the SIR, yeah, Tishon just posted a link. You can go there if you want any info and data about COVID-19 spread, and if you're at risk, and everybody is at risk, but like, yeah. So if you want, so the
Yeah, so these were the websites I showed you earlier on like where you can get the data, because it's kind of hard to just search up and try and find the data. All right, and that's about it for today. So time's up, everybody, and you guys can all go now. So thank you all for coming and coming to the club, and goodbye.